Welcome to State of Open subset from OpenUK. My name is Lorna and I'm a board director at OpenUK as well as an open technology leader. I am very happy to have you join us today. State of Open subset is part of our annual conference State of Open Con. We had many more great talks submitted than we had track space for, so we are very pleased to share at least some of those talks with you in this series. Each subset episode will be available on our website at openuk.uk/subset and on our YouTube channel. Our speakers will join us live and will be around after their talk to answer your questions. Although we're meeting digitally, all of the sessions are subject to compliance with the OpenUK Code of Respect, which is conveniently located at the bottom of every page on our website. I hope you'll also share on social. If you are, then use the hashtags OpenUK and State of Open subset. Today's speaker is Tom Meadows from Jetstack. Tom is an engineer with expertise in cloud native technologies. He has an interest in security in general and supply chain security in particular. He is passionate about open source and making technology better for users. Tom's talk today is The Scanner is Not Enough, Approaches to SBOM Generation. With the software bill of materials a very hot topic for software projects everywhere, this topic is both important and timely. Enjoy the talk. Join us for some Q&A time at the end. But for now, I welcome Tom.
Hello, everyone. Thank you for taking the time to listen to my talk. My name is Tom Meadows, and I'm a solutions engineer at Jetstack. The title of my talk today is The Scanner is Not Enough, Approaches to SBOM Generation. I'm going to be walking you through the concepts of SBOMs or software bill of materials, and why I think that, simply put, the scanner is not enough, and why some other approaches to generating SBOMs should be considered. So starting off, I felt like it was obvious or the right thing to do to just talk about software supply chain security and also my journey in software supply chain security. So it was about a year ago or so now that my manager asked me to explore the subject. I had no prior understanding of software security, which might make you wonder why I'm sat here giving this talk today. But I decided to press on and have a look at the subject and see what the area of software supply chain security was all about, as it was all the rage. So the picture you have in front of yourselves now is sort of the state of things when I first arrived. So I was running around like a maniac, realizing that companies all over the world were bringing in all sorts of different pieces of software, and they had absolutely no idea what those were and how to track them. Moving on a year or two from then, where am I now? So this is how it's going. I'm pretty much at this sort of state of disbelief where I feel like everything is broken. Fundamentally, security is all flawed, and I'm sick of people pretending that it isn't. Obviously, that's a very pessimistic view, and I try my best to keep myself positive and optimistic rather than pessimistic like Mr. Joker down at the bottom here. So along that vein, I'm going to try and bring something that primarily I have some pessimism, about, but bring in a level of optimism. And that is all along the lines of the subject within software supply chain security of why do I think the scanner is not enough? So I think the best way to start that is by looking through what the typical supply chain looks like for a piece of software. So in front of you, you've got a selection of boxes, and they are meant to represent what a typical software supply chain might look like. So on the far left at the bottom, you've got the green box, which is your source code. So this is all the code the developer is going to be writing. And in 2023, it's pretty common practice that a developer will actually take other people's code that's already been pre-written in the essence of saving time and the quality of the code being better, especially if it's a poor software developer like myself. I'm more of a DevOps engineer and I try my best with software, but there you go. So saying it's me, I look at someone else with some really nice software that they wrote, and I want to depend on that so I can use it and expand on it myself. So those are my dependencies. For any piece of software, I might use anywhere between 2 or 3, all the way up to tens, if not hundreds. Especially if you're looking at front-end web development, like the likes of JavaScript with npm and yarn. So I write my source code as the developer, and then what do I want to do next? Well, I probably want to test it. So I can perform unit tests along against the source code to check that it's doing what I thought it was doing when I wrote it. And maybe I want to do some full integration tests as well to make sure the functionality works in the way that I expect it with other pieces of software that might be being written within my organization or indeed by myself. Once I'm happy with the quality of the code and I'm happy that it's doing exactly what it is I think it's doing, that's when we're going to go on with building the piece of software. So that looks like taking all of our source code, giving that to a piece of software that is known as a compiler. It takes all of our source code, so all of our text written by the developers, and it puts that together into some sort of opaque blob that in the software will be called a binary. From there, it's likely that I'll want to package it. So these days, we have packaging formats that we put our software inside of, our binaries inside of, to make it more easily consumable. So if any of you who have used command line based package managers like apt or yum or dnf, the developer might want it to be easily consumable by those package management systems. So they'll bundle that binary into a package in some form. But even if I don't want to use a package manager like in that way, I could want to put my binary inside of a container image. Maybe I want to run it on Kubernetes or with Docker. If I want to do that, then I need to put my binary inside of a container image. After I've done, I've chosen my method of packaging up the software, that's when I push it off to its final destination, which is the repository or the storage location where it's going to be released to the world. So all of the people who decide it's a good idea to run my software, personally, if I was them, I wouldn't trust it because, as I said, I'm a poor software engineer. The release, the release repository is exactly where they get it from. Why am I showing you all this? Well, mistakes or malicious attacks at any point in the supply chain can expose software consumers to risk, especially if it's my software. But I'll stop degrading myself like that. I think I'm actually all right. Probably shouldn't be so mean to myself. Anyway, what's an example of one of those attacks that sort of negatively affects users by exploiting that supply chain segment? Well, a lot of you might have heard of Log4Shell. If you haven't, don't worry about it. You'll be able to find plethoras of blog posts about it on the open internet. But essentially, there was a software dependency called Log4j for Java. A vulnerability was discovered in Log4j. It's, as it says in the first bullet, it's an extremely popular dependency. So there were potentially millions of users all around the world that were depending on it in their software. And that vulnerability allowed users to easily execute arbitrary Java code within the application. So as you can imagine, panic unfolded, but don't you worry. We were very lucky in this case because Log4j is a very well-maintained dependency or piece of software that people depend on, with a good group of people that were willing to come in straight away with a fix. And that fix was quickly released. However, the fix is only as good as the amount of people that then go and implement the fix in their software. They need to update the users, i.e. the developers depending on that software need to update the version of Log4j that they're using. So an immediate response was required by those depending on the software to identify which applications they had depended on the vulnerable version with and update them. Most importantly today, it serves as an example of why the inventory and tracking of dependencies coming into your environments is crucial. And even today, people, we fear, still struggle to identify where this vulnerable piece of Log4j code may be running. I think to say that every single Log4j dependency has been folded out is an incorrect statement, and it definitely serves as a skeleton in the closet that might come back to bite people running their applications in all sorts of different use cases. So moving on with the notion of supply chain security, some individuals or organizations in the world desperately try to think of ways that they can improve the world, so the world is less vulnerable to situations like this. And a very important group of people, headed by a man known as Mr. Biden or President Biden, released an executive order on improving the nation's security the nation's cybersecurity in 2021. So what did this mean? Well, in short terms, what it meant is that the US government provided guidance to all of the US government agencies that they manage as to how they can improve the security of their software supply chains. So the software that they themselves are depending on and the software that they are consuming within the government agencies. Inside of this executive order, it included a recommendation that those US government agencies require the software vendors that they're getting software from, i.e., that could be an open source project, that could be an enterprise software vendor, to publish a software bill of materials. The recommendation is that if that software bill of materials isn't there, the US government agency should not proceed with using the software. Given the amount of money that the White House and the US government have, you can imagine that people all over the world frantically tried to make sure that they had their software covered with the software bill of materials, as everyone wants their software to be consumed by the likes of US government agencies for them, in a lot of ways, the meaning of profit. For some others, it means the success of the project in the case of open source, of course. So, one elephant in the room that I haven't really addressed at this point is what in the hell is a software bill of materials? And if you don't understand what it is, don't worry, you are definitely not the only one. It took far too long for me to understand it myself. So let me elaborate and see if I can try and iron out that unknown for you. So a software bill of materials is an equivalent to a bill of materials in a traditional supply chain. It's essentially a list of ingredients that a piece of software comprises of. So all of those dependencies that developer is referring to in their code to utilize, those are your ingredients, and it's that list. It's a list that's compiled as to all of the dependencies that they are using. A document, it's a document that's distributed with the software it refers to. So the idea is with my piece of software, I should have the document, the bill of materials right next to it, so I can peruse it at my leisure. And the use cases are, it should make it easier to identify for that piece of software which components are in it, and therefore which vulnerable components or out-of-date components are within that piece of software. So in our situation with the log4j problem, with the vulnerability of log4shell, that should mean quicker identification of the vulnerabilities and making sure all of those holes are filled and no problems can be left to bite us back in the future. It's also an accurate list of components to use as a target for vulnerability scanning. This should drastically reduce the time to scan and could mean huge positive implications in terms of the use of compute and therefore, especially in cloud environments, the amount of money spent for organizations. It also provides a means of, when one is using open source dependencies, which in most cases they almost always are, it allows for license identification. So if I've got an open source project I want to depend on, they all have different licenses as to how they expect and don't expect that software to be used. If I have those licenses, I can decide which ones are the risky ones or which are the less risky, and organizations like to be able to have that, and software bill of materials can cover that base as well. Finally, it allows you to understand the relationship between dependencies if you want to have a dependency graph embedded into your software bill of materials. But that's probably one for another day. For those of you at this point that are still struggling with the notion of what a software bill of materials is, I'm going to try and simplify it for you. So in front of my screen, and surely it doesn't get any more simple than this, I have for you my lunch. So it's a delicious cheese and meat, tomato and pickle sandwich with some lettuce thrown in, some extra extra vegetable goodness. Why am I showing this to you? Well, that sandwich compiles of, as I said, those pickles, that lettuce, the chicken, or the salami or whatever it was, and the bread. They are my ingredients. So they're all the things that I would list in my list of ingredients. Let's say I wanted to start selling the sandwich. It was a really delicious sandwich, and I think we could have a go-to-market strategy, and I could make millions. Well, one would assume that I probably want to get a list of ingredients down for that sandwich so people know what's in it. So as I said, that would be the pickle, it'd be the tomato, it'd be the, salami, the cheese, looks like chili cheese. but probably a little bit more difficult to determine what was in the cheese, but you get the picture. And if I was to put that on a supermarket shelf, you'd expect to be able to glean that information from it without even looking at the contents. So our list of ingredients is like so, and this is an example of what my software bill of materials might look like in a sandwich form, of course. So we've got our chicken, we've got our bread, we've got our lettuce, our cucumbers, tomatoes, green peppers. The observant of you would know that this is not the same as the sandwich I had for lunch, but we can just breeze right past that. However, you probably have gone to your local supermarket, the big ones, and seen an ingredients list that's not quite so simple. It gives this atomical view of all of the things that are in the sandwich at a really, really specific level. This is what might be expected of a highly professional organization that gives everything all the way down to the final letter. If I'm allergic to niacin or whatever that horrible looking chemical is, maybe it's not chemical, I don't know, I probably want to know about it. And the same could be said for the software bill of materials. I want a highly accurate representation of everything there is in my software, in my piece of software, so I can determine whether I should or shouldn't be using it within my organization. So without further ado, we've got our amazing software bill of materials in front of us. And I know what you're thinking, how terribly underwhelming this load of random text is. I think I've said to some people before, please don't take this on holiday. You won't enjoy reading this while sipping your pina colada at the beach, but especially, and this is what it's meant for a machine readable purpose, this is actually pretty great. So as you can see in front of you, and hopefully you can if the size of the text is good enough, you can see that this is a Cyclone DX, which is the format of the software bill of materials. And it is of type container, which you should be able to see here. Why is it of type container? Well, this is the software bill of materials for the Grafana container image. So this is for a container image bill of materials. It's got the immutable digest of the image. For those of you who use containers, you'll be familiar with. And underneath, it's got all the components, or at least one of the first of many components in the SBOM that are inside of the software bill of materials. I've shortened it just to save you all the pain. So this is one of my ingredients, and underneath you'd have many other ingredients. You can also see that I've got the license identifier for this component, which is a library called Alpine Base Layout. It's got the version, and it's also got some pretty awesome unique identifiers I can use for searching vulnerability databases. So who's doing this? Well, apparently, in 2022 at least, 78% of organizations expected to produce or consume SBOMs in 2022. What I would recommend off the surface, if you click off this presentation now, is you should be aiming to consume those SBOMs first before you should be consuming them. However, for the rest of the presentation, my focus will be on that production side. So production. Creating things. Let's do it. How do you create your magic SBOM? So at the moment, the two most popular ways that one might be creating their SBOM is like so. Number one is that the scenario that I'm producing an SBOM for a container you publish and distribute. So I build my software, so compile all of my source code that my amazing developer has written, hopefully not me, and I throw that into, I build that into a binary, and I package that into my container image. Once I've done that, I use a magic, amazing vulnerability scanner or a software component scanner to find out what all the contents of that software is, because I'm not the developer and I definitely wouldn't know. And I throw that into my SBOM, or if I'm lucky, the scanner creates that SBOM for me. Finally, I release the software, so the container image, alongside my SBOM, so people can use the software and most importantly know everything, and I mean everything that's in it, because this scanner is magic. The second scenario is if I'm generating an SBOM for a container you consume. So as I said, you should be focusing on the consuming before the production. The reason why is because you can mandate, especially if you're paying for the software, you can require the vendor to do this SBOM generation for you, and they should oblige, especially if they want your custom. So if they were to do that, let me correct myself. If they weren't to do that, or if you were to use an open source project and you wanted to know what's in it and keep inventory of that, what it would look like is you would pull down the container image from the repository. You would again do the exact same thing. You would scan it, because the scanner picks up everything. And you would generate your SBOM and you'd go to deployment stage with the image, and you'd probably stash away that SBOM for further analysis and audit. Profit. So you can probably already tell my skepticism of the fact that we did manage to get profit there. And I'll tell you the reason why I am so skeptical by explaining to you how scanners work. Put simply, scanners look for things of interest. They poke around in well-known locations. If it's a container image, at least, or if it's in any sort of file system structure, they look around in well-known locations for particular metadata. This might look like checking known package manager metadata files, which are embedded within a container image. And then they might also walk through the entire root file system. This isn't, again, in the scenario where you're doing this for a container image. When they walk through, they'll compare checksums to known values that they have stored inside their own binary or in a server location, things that are looking a bit smelly. So Sneak, for example, have the sneak log4shell command, which will traverse through a file system and checking whether or not there are any vulnerable log4j binaries or dependencies stashed away inside of that executable. They might inspect build information embedded inside of binaries. So some languages, they embed this information with a binary, which if you throw a function call against the binary, it will grab the dependencies list out of it, which is actually pretty magic and pretty cool. Go is, I think, the main example that I know of that does that. And they also finally do, maybe while walking through the file system, some string matching. So trying to find semantic versions to know what version of a dependency or a piece of software inside the container images, package URLs, license types, etc. There's a popular piece of software called Fossology, and it does just that for licenses. It will go through a file system for a virtual machine image or a container image, and it will look for those licenses and then add them to a list. I've actually heard for large container images, I've heard of scans lasting as long as 44 hours. I think that was the number anyway. So as you can tell, this can end up being a very long and torturous process. More importantly, can be very expensive. As this is that would be 44 hours of straight computation. These methods of searching for information are limited and they'll miss things. This is why I'm so skeptical. There's no such thing as that magic bullet piece of software, at least in 2023, that you can throw against a container image to find dependencies and software buried within it, and it will find absolutely everything. They can, most importantly, also just find what is there. If that thing is missing or isn't present, but it was required in order to make the thing that is the thing you're going to execute, then it can't find anything at all. Which brings me on to the limitations. So as I've said, discovery is the main limitation here with scanners. So internally, we did some sort of investigation of how this is specific to container image scanners. I want to make that completely clear now. The rest of the presentation is focused specifically on container image scanners. We performed some investigation of some different scanners and how they perform while searching against the same image. So as you can see in front of you, we did the search for 2 images and compared that across a bunch of different scanners. And as you can see, there's a wide variety of results. What we can glean from this is that with a decent level of certainty, we can say for sure that no single tool discovers all the components. It's very unlikely that, given this wide variety of results, that there's one here that's got no outliers. Because while Grafana, Sift picks up everything, Trivy picks up not as much, and then in the Coinbase Salad example, it's the inverse. So Sift doesn't pick up as much, whereas Trivy picks up more. So as you can see, it's just not it's not a situation where one tool rules them all. You could say, oh, we'll just run multiple tools and we'll aggregate the results. That's a difficult thing to do because different tools identify packages slightly differently. With different levels of information. So augmenting and merging those SBOMs could get really, really tricky. The list of ingredients the merging of them could get really tricky without losing information, or indeed including duplicates. without a manual and very sort of horrible process that a poor person would have to spend many, many hours doing in order to get the reasonable result. So another limitation here is when software is installed outside of package management. This is again along the discovery sort of line of things. A software package is usually installed by utilizing a package manager. So that is, I mentioned them earlier, the likes of APT or apt, RPM, DNF, Yum, and APK. Because those package managers need to keep track of whatever it is they're bringing into the file system to be used by the user or the machine identity or whatever, that metadata is supplied alongside the package to describe it so it can keep inventory, and then the package manager keeps an inventory of what it's installed. So in that case, we're pretty good to go with the scanners. Where we're not good to go with the scanners is when, and this is a very common thing that happens in a lot of businesses, is when a developer or an engineer will pull in a piece of software without using anything that's keeping track of it, like a package manager. At the bottom of the screen, you should be able to see a small bash script with a curl command within it. This is me as an engineer that's decided that I need JQ inside my sort of whatever executable it is. Let's say on my container image, I realized you needed JQ. So I've curled in JQ and it's available for me to execute and use. But how is a scanner meant to find that? Scanners are only able to look where they know to look. If I installed it with APK, apt, or RPM, then I'd be able to find it. In this case, it's going to go completely under the radar. And that goes for anything else that you decide to manually copy or pull off the internet without using a sort of a reliable package manager. Another limitation is along the lines of something I discussed earlier with being able to pull out the dependencies listed within a binary for the case of Golang. So Golang is a programming language, and it's a great programming language. It's my primary programming language, and it has this epic functionality where if you build something, it actually embeds a list of those dependencies in the binary. This is great. Unfortunately, it can be stripped out really easily. So you can take one extra step in your build pipeline to just strip out all this information entirely. In fact, I actually had a conversation with a colleague recently who I shall not name, who said that he actually removes this dependency information because he can't be bothered having people coming to him talking about potential vulnerabilities. Haha, very hilarious, but it's the truth. If it's easy to take out this information, and in some cases, some build systems like Bazel do it automatically, because why do we care about it? It's just extra bloat. I want my binary to be as slim and small as possible, then I might just take it out by default. And as a developer or engineer, I wouldn't know any differently. It also doesn't include the information about the dependency relationships. So I mentioned this dependency graph before. So I have a piece of software that I'm dependent on, but what's that software dependent on? And what's the others that next software dependent on? There's a whole tree of dependency relationships that if you want to take this stuff seriously, really seriously, in fact, you can map out, but this isn't an option in this case. So this has been a pretty negative presentation overall. So hopefully the doom and gloom stops here, and I can start talking to you about the upsides of everything and why everything is not the end of the world. I'm going to start by talking in terms of the positives about what you can do to improve your SBOM generation, and that is indeed by shifting a little bit left. So what do I mean by shift left? What I mean by shift left is deciding to build your software bill of materials earlier on in the process, not after you build your software and package it, before that. So how might you do that? Well, it is in fact possible. I showed you a container image scanner called Sift earlier, and it actually lets you select a file system to scan to look for dependencies. So rather than a container image where it's expecting to look for binaries, I can select a directory. Why do I want to do that? Well, it's actually able to scan source code repositories for information about dependencies. So I can go to my Git repository and I can run a Sift scan against my Git repository. There it has all my dependencies written in the form that my developer wrote them in initially, and it's got all sorts of other metadata files. In the case of JavaScript, you've got a package.json. which it can pick up all this information from. And all of a sudden, the amount that I can glean is an incredible amount more. As you can see here for Grafana, we have 303 components found for the container scan. That's after the build, that's further right. And in the better case, we have almost 3,000 dependencies found or components found in the source code scan. So that's a pretty good result. However, I'm sorry to bring in more doom and gloom. Blindly scanning source code before a build happens could lead to false positives and inaccurate results. What do I mean by that? So inside of this 2,921, it's quite an incredible number, source code components found. This could also include dependencies of the development itself and tests. These dependencies won't actually be sort of part of the compilation that is our final binary, and they're not relevant to the produced artifact. And indeed, there's little to no chance that crossover between them could cause a vulnerability to end up in the produced artifact. But that's actually an interesting subject because it could, so you may want to care about it. So it's not exactly a black and white answer either. Many repos include source code for multiple artifacts. So if my source code repository is a monorepo, I could have some problems there. And in Go, indeed, there's this idea of the Go module, which is usually a one-to-one mapping with the source repository. If that's the case, I could have lots of different binaries built off that one module that are jumbled in together, and we need to understand which are actually being selected during a particular build in order to build the software bill of materials for each one. For release software, we want to understand what's actually present in the artifact. So shifting all the way left might not be the answer here. So what have we talked about up until now? Mostly negatives. Producing SBOMs after the fact will miss things and create a false sense of security as to how good or bad your piece of software is. Producing SBOMs before the build might include dependencies that aren't relevant to the build artifact. This could lead to discovery of CVEs that don't impact the artifact. And then if we want to get this right, maybe we just put things in the middle. So maybe build time is the answer. So at build time, you have all the information required to say what it is and isn't included. So I don't have my test and development dependencies, and then maybe I can produce an accurate and comprehensive SBOM. So build tools. Looks like that might be the solution here, right? Sort of. So ideally, the tools you use to build your software in the build pipeline, they would include the option to produce an SBOM. Why would that be? And just as to show an example, we'd have like npm build and go build, and they just spit out an SBOM at the end, and it'll be magic. Well, that would be trusted magic. Why? Because build tools are the best person or the best place to understand what it is and isn't being included in a build, and produce a reliable graph of direct and transitive dependencies. Sort of what I mentioned with how go build embeds that into the binary. But it would be nice if it was a separate file in a format that I could choose and configure. This capability, however, is not currently available in native build tools like Go, npm, and Yarn. So what are my options then if I really want to do this? So there are some ways around it. There's a great tool called Co. Co allows you to take Go source code and compile that all the way into a minimized container image. So it makes it really easy to go from source code to container image. That generates an SBOM, I believe, by default, and you can configure it to be SBDX format, which is another kind of SBOM format, or CycloneDX, like I showed you earlier, for the container it produces. So that's pretty cool. And that's sort of along the lines of how I would expect things to be in the future. I just build my thing, and the build system knows that I want an SBOM for it. Especially if that's to become the standard. Another example is APKO. It's built by, similar. Both of these are open source, and I think some of the same developers were involved in the process for each. What this does is it allows you to build container images from APK packages, but like very minimally, where the APK packages are really the only thing in the image. You can then use the APK metadata to generate the SBOMs, and each component is an APK. That way I know everything that's in the image, as it's all defined in APKs using that package manager identification method that I showed you earlier. Finally, one word of warning is that you'll see a lot of tools claiming to have SBOM functionality, and it's true, they do. It's just that as an example of Docker and Go releaser here, but there's others, that SBOM functionality is just a container image scanner under the hood. So at the bottom, you see Docker SBOM Neo4j. What that's doing is it's building the container image or indeed just scanning the container image in the same way as SIF does, but making it look like it does something a little bit more exciting. It doesn't do that. Again, with the Go releaser project, which some of you might have heard of, I can configure that to generate an SBOM for my artifact. But again, all that does really is just a container image scanner under the hood. So in lieu of native features, there are plugins and tools that can approximate what a build tool is producing. More examples are the CycloneDX project, having some extra tools for various languages and frameworks that might be able to help you here. So 2 examples in the CycloneDX case are CycloneDX Go and CycloneDX Webpack. They know exactly how to interface with Go in order to produce a software bill of materials that's going to be true, accurate, and reliable. As I said, they're able to identify which dependencies are being selected more accurately than scanning before or after the fact. And they can also, even more powerfully, resolve that very important dependency graph if you're going to be really in detail with all of this stuff and provide information about the relationships between different dependencies. So, caveats. Where are the caveats? There are a lot of caveats in this subject, but I'll go through a couple of them. The first one is developer. This is mainly a caveat with the shifting left to build time sort of idea or initiative. The caveat here is developer autonomy. It's basically impossible to generate a software bill of materials at build time without modifying the existing pipelines and therefore also knowing exactly how those pipelines function. If you value the autonomy of developers, it can be difficult to impose SBOM generation on them and their pipelines, and ensure as well that generating them is done correctly. It's going to add more work to the developers, and shifting the burden to them could be, in a lot of cases, seen as unfair. It requires, as hopefully you've gleaned from this presentation, a lot of knowledge and effort to ensure you're doing it correctly. And I think, at least for me and colleagues I work with, tooling for this should be turnkey. So it's easy to turn on SBOM generation for your chosen build tools. It should just be an option that people can buy into, especially for developers and those that are modifying and building the build pipelines. The potential solutions here for the developer autonomy problem is including an SBOM generation template or boilerplate configuration for the build pipeline. So what this looks like is you say, here's an example of how to do it, or here's a base pipeline you can base it off, and you can go from there. So you can just integrate all of the extra stuff you want around it. But in a more restricted environment, it might be easier to provide a set of predefined build options with SBOM generation included. So as I said before, you might say to your developers, you must build your software, your Go image with Co, or you must use the CycloneDX tooling. And if you decide to do so and you figure out how to get it right, which might need some signal attenuation, you could choose SIFT as well. But making sure in a more restricted environment, you might want to say, here are the requirements you need to hit in terms of the build options that you select in your pipelines. So the second caveat I'm going to go through here is trust. And this is more along the lines of the consumption of SBOMs rather than the shifting left. So why should you trust the SBOM that a vendor provides to you? If a vendor such as JFrog says, here's the SBOM for X-ray, I look at it, I'm not going to go to myself as a security person and say, that's brilliant. It's got everything I need and more. I'm going to ask myself, is this truly accurate? So signing can help ensure that the SBOM hasn't been tampered with and it was produced by the vendor and that it's what they said it was. But then again, as I said, ensuring that the methods were accurate and comprehensive, it's a tricky one there. The more vendors you consume software from and expect the SBOM from, that's the more entities you have to trust and as this slide said, you might choose to audit if you want to take this stuff very seriously. Potential solutions here might look like nominating a number of managed build services that you trust to produce decent SBOMs from. An example of this, if GitHub Actions, it doesn't right now, but if it did in the future, and the same with Google Cloud Build, if it provided SBOM functionality that was graded and audited to be correct and accurate and trustworthy, then your business could say, okay, well, we only trust SBOMs from these build systems. Trust is easier to establish with internal build systems and teams. You could rebuild artifacts yourself with SBOM generation and then compare the two. So sort of use the scanners as an auditing tool and see what the difference is. And you could use that result to validate the accuracy of the provided SBOM. The final caveat is, say you find a vulnerability, or upstream someone finds a vulnerability in a piece of software you're using. How would you then spread the information of the status of that vulnerability along the line? So the presence of a component with a known vulnerability does not imply that the vulnerability is actually exploitable in the application. So you probably have all seen it before when you get this vulnerability scanner and it says you've got 15,000 vulnerabilities. The fact that they are all vulnerabilities you're directly vulnerable to is probably incorrect. I'm sure there are some, but I'm sure there are others where it doesn't quite apply to you and it doesn't really give you the detail as to how or whether you're going to be affected. And also in the future, in newer versions of software, there's no real way of knowing whether those vulnerabilities have been folded out or indeed which version. It's very possible that the vulnerable code path isn't called at all. So how do you as the consumer know that? So this is where VEX, or the Vulnerability Exploitability Exchange, comes in. This communicates whether a subject is or is not affected by a particular vulnerability. If I have a piece of software that I've written and it comes up that everyone's telling me that I'm vulnerable to something inside of it, I could do some investigation, and when I deem that it's not a problem, I can add inside of my SBOM a VEX document saying that the code that's vulnerable inside the dependency I'm using that's vulnerable is not reachable. You might think, well, Tom, why don't you just move off the vulnerable dependency? But the reality is my software might be so dependent on that dependency that it creates an enormous amount of work for me to move off it. And if I can deem that I'm not vulnerable, or my software that in the way I'm using it is not vulnerable to the problem, we might be fine to just continue going. But that's something I need to tell my users of, those that are consuming my software, what the story is there. So this is the way that I communicate and resolve this caveat. So in summary, SBOMs provide valuable insight into the contents of container images and other artifacts. Producing SBOMs with scanners is a positive step for supply chain security, but it's ultimately a limited approach. Shifting SBOM generation to build time produces more accurate and comprehensive results, and tooling needs to improve to make it easier to integrate SBOM generation into existing pipelines. Although there are some options out there, depending on the languages and there are some out there depending on the languages and ecosystems that you're using. And finally, the VEX format can complement an SBOM, making findings from vulnerability scanners more actionable. There are still some unanswered questions though. How can you trust the veracity of an SBOM or a VEX? And this is my thank you slide, but my final advice to you would be to make sure you've got a good fence before you start building your gate. The supply chain security sort of area is still something that's being very heavily developed on, and the golden path is still to be found. So spending a lot of your time on doing traditional security pieces, like configuring access control and making sure your build system itself it can't be compromised, is a much better use of your time than spending till kingdom come generating your response. And my final word to you is, don't let my pessimism defeat you completely. If you decide to go down the container image scanner route, please do so, but proceed with caution. Remember that whatever it is you're producing will have outliers and will have a layer of unknown that it's not finding. And if indeed generating complete SBOMs is a route you need to go down, just be aware of the fact that container image scanners might not be your golden solution there. So without further ado, thank you very much. And hopefully you've got some questions. If you do have questions that you don't manage to ask after this recording, please hit me up on my email, tom.meadows@jetstack.io. Thank you very much.
Thank you so much for joining us for today's session. If you think that you have a talk that would fit with Subset or State of OpenCon, let us know. We will open the CFP for next year's State of OpenCon this summer, but if you want to speak on Subset, you can drop us a note. You can email admin@openuk.uk. Send us your bio, your talk proposal, and why you want to join us. You can also sign up for the OpenUK newsletter. It's at the top of every page on our website. You can hear more about the organisation or come along to one of our meetups and meet the team. Our next talk will be on the 9th of May, and it will be Peter Farkas talking about open standards and open source. I hope to see you then.